You already know how to find the volume of boxes, prisms, and other solid figures with flat faces. But what about a can of soup, an ice cream cone, or a basketball? The world is full of curved solids, and calculating their volume requires the same big idea you had already mastered: area of the base times height, along with a very special number you have met before. In this video, we're going to extend everything we know about volume into the curved world of cylinders, cones, and spheres. Let's start with the big picture. Geometric solid. Any three-dimensional figure that encloses space. Geometric solids include prisms, pyramids, cylinders, cones, and spheres. Curved solids show up everywhere, from the cans in your pantry to the planets in our solar system. Before we dive into formulas, let's make sure two familiar tools are sharp and ready. Pi, the special number approximately equal to 3 14/14 that describes the relationship between the circumference of a circle and its diameter. Beyond working with circles, pi is used to calculate the volume of cylinders, cones, and spheres. Wherever there is a circular base, pi is part of the calculation. Radius, the distance from the center of a circle to any point on its edge. The radius is used in the formulas for the volume of cylinders, cones, and spheres. Knowing the radius of a circular base is the essential first measurement for finding volume of a cylinder, cone, or sphere. Height of a solid, the perpendicular distance between the two bases of a solid figure, or from the base to the highest point. Height is a key measurement in volume formulas for cylinders and cones. It is always measured as a straight vertical distance, not along any slanted or curved surface. Now let's meet the curved solids one by one. Cylinder, a geometric solid with two parallel congruent circular bases connected by a curved surface. We use the formula volume equals pi r squared times height to calculate the volume of a cylinder. Notice that this is the same big idea we've used all along. Volume equals area of the base times the height. The base of a cylinder is a circle, so we use pi r squared to find its area, then multiply by the height. A soup can, a candle, and a roll of paper are all cylinders. Right cylinder, a cylinder where the two circular bases are directly above one another and the sides are perpendicular to the bases. Most cylinders we encounter in everyday life, from cans to drinking glasses to pipes, are right cylinders. Unless told otherwise, we assume a cylinder is a right cylinder when calculating volume. Right circular cone, a geometric solid with one circular base and a curved surface that comes to a point called the apex, directly above the center of the base. Here is a remarkable fact. The volume of a cone is exactly 1/3 the volume of a cylinder with the same base and height. That gives us the formula volume equals 1/3 times pi times r squared times h. An ice cream cone, a traffic cone, and the tip of a sharpened pencil are all examples of a right circular cone. Slant height, the distance from the apex of a cone to any point on the edge of its base, measured along the curved surface. The slant height is different from the vertical height of the cone. Think of the slant height as the distance you would travel if you walked up the sloped surface of the cone from the base to the tip. Because the slant height, the vertical height, and the radius form a right triangle, the slant height can always be found using the Pythagorean theorem. Sphere, a perfectly round geometric solid where every point on the surface is the same distance from the center. A basketball, a globe, and a soap bubble are all spheres. The volume of a sphere depends entirely on its radius and is calculated with the formula volume equals 4/3 times pi times r cubed. Unlike cylinders and cones, a sphere has no height and no base. The radius alone tells us everything we need to know.